Lesson 1-7, you'll be writing equations from verbal sentences and situations. An equation is a mathematical sentence containing two expressions that are separated by an equals sign. This lesson can be a little bit tricky. The first thing I start out by doing is reading the question. Eduardo had a score of a negative 150 points in his first round of a game. His final score after 2 rounds was 75 points. Write an equation to find his second round score. After I read the question, I ask myself, what is it that I don't know in this problem? In this problem, I don't know what his second round score was. So that is what I'm going to use for my variable. I'm going to use an S for his second round score. So I'm going to define my variable. S equals the second round score. Now, after I know what it is that I don't know, I'm going to go back and read the problem and see if I can make sense of what they're saying. Eduardo had a score of negative 150 points in his first round. His final score after 2 rounds was 75 points. Well, if I were to try and work this out, I would want to add round 1 plus round 2 together to get his final score. Round 1 we know was a negative 150. Plus round 2, which I don't know, so I'm going to call that S, is going to equal his final score, which was 75 points. Negative 150 plus S equals 75 is your final answer. That's your equation that represents this situation. If you want, you could pause the video at this time and try the next two on your own. The winning time of 27 seconds was 2 seconds shorter than Tina's. First, I ask myself what I don't know. I don't know what Tina's time was. So I'm going to define my variable. I'm going to have T equaling Tina's time. Now I'm going to go back and read the problem. The winning time of 27 seconds was 2 seconds shorter than Tina's. So let's just translate that. The winning time of 27 seconds was, when I say was, that's going to clue me into an equal sign, 2 seconds shorter than Tina's. Well, if Tina's was T, 2 seconds shorter than Tina is T minus 2. Some kids might mess this up right here by putting 2 minus T if they just read it in the order it is, 2 seconds shorter. It needs to be switched around though, because 2 seconds shorter than Tina means to take Tina's time and take away 2. The next example, a drop of 4 degrees Fahrenheit per hour for the last several hours resulted in a total temperature change of negative 24 degrees Fahrenheit. The thing that I don't know in this problem is the number of hours. So I'm going to define my variable as H equals the number of hours. Now when we go back and read the problem, a drop of 4 degrees per hour for the last several hours resulted in a total temperature change of negative 24. If it's 4 degrees per hour, it's going to be 4 degrees, or 4 times the number of hours. Resulted in, that's going to be our equals, a total temperature change of negative 24. I'm going to back up here 1 second because I just missed something. It says a drop of 4, so it's not 4 times H, it's negative 4 times H, since it was a drop of 4 degrees Fahrenheit. Our next example says the change in attendance from last year's spring dance was negative 45 students. The attendance this year was 128 students. Write an equation that could be used to find the attendance last year. So after I'm done reading it, I ask myself, what is it that I don't know? I don't know what the attendance was last year, so I'm going to use A for the attendance last year. It's very difficult to write with a mouse. You should try it sometime. Now go back and read the problem. The change in attendance from last year's spring dance was negative 45 students. The attendance this year was 128. Write an equation that could be used to find the attendance last year. Well, if we take last year's attendance and add to it the change, it should equal the new attendance. So last year's attendance plus the change in attendance is going to equal the attendance this year, which is 128. Now our last example is a multiple choice, which might be similar to something you would see on a standardized test. The number of pounds of insects a bat can eat is 2.5 times its own body weight. Given B, a bat's body weight in pounds, which equation can be used to find P, the pounds of insects it can eat? Well, it says that the number of pounds of insects a bat can eat is 2.5 times its own body weight. So 2.5 times its own body weight. Well, its own body weight is going to be B, because it says B is the bat's body weight. So the amount of insects it can eat, the pounds of insects that it can eat, is going to equal 2.5 times the bat's body weight, or choice D.